Right triangle, trigonometry. Here we go. We're going to learn the trig functions today, or some of the main ones today. If you have a right triangle, and I think you all are familiar with a right triangle, it's simply a triangle that has a 90-degree angle in it. First, let's just talk about a triangle. This is true of every single triangle. It doesn't have to be right. Any triangle you can create. If you add up all three angles, it will equal to 180 degrees. That is always true. Okay, that's important for us to remember. And then this is also important for us to recall for a right triangle, the side across from the 90-degree angle, we reserve the letter C for that. And this is called the hypotenuse. That's important for us to remember. This is called the hypotenuse. And then the sides of the triangle that form the 90-degree angle, these are referred to as the legs of the triangle, and these can be interchanged. However, when we are doing this type of trig, this is the convention we will keep. Capital letters will represent angle values. So C is 90 degrees. Angle C is 90 degrees. Angle A is this angle. Angle B is this angle. Let's take note of something, though. If this is a right triangle and this is 90 degrees, there are only 90 degrees left between these two. So that means that A and B have to be an acute angle. They have to be between 0 and 90 degrees, acute angles. So that is important for us to take note of. This is going to be somewhere between 0 and 90 degrees, and this is going to be somewhere between 0 and 90 degrees, because that is a condition for the trig ratios we're about to learn. Okay, so here is the first trig ratio. Sine of some acute angle in a right triangle. So B, let's look at B, the sine of B. Oh no, let me not do B. Let me just do a generic angle theta. That is between, and it's an acute angle, the sine of some angle in a triangle. It is equal to opposite, the length of the opposite side, over the hypotenuse, the length of the hypotenuse. And if we have some acute angle, cosine of theta. So let me just draw another generic little, here's theta. Let's just say this is theta. What is opposite? If you follow the angle till you hit the wall, this is the side that's opposite it. What is the hypotenuse? It is always right here. The hypotenuse is always across from the 90-degree angles. And the cosine of angle, some acute angle theta, would be adjacent, which means beside, adjacent, am I spelling that wrong? Yeah, there's a D. I think that's supposed to be a C. Adjacent over hypotenuse. All right, so here's my angle. The choices that are beside it, what's beside this angle is this side and that side. This one doesn't change. He's special. He's the hypotenuse. So this is the adjacent side, adjacent to angle theta. And this is the hypotenuse. So cosine is adjacent over hypotenuse. And then there's something called the tangent, which we abbreviate TAN. This is equal to opposite over adjacent. Okay, so let me write down the full names of these trig functions. The sine, that's the full name of sine of theta. This is the full name of cosine of theta. And this is the full name of tangent of theta. But we abbreviate this as just SIN, COS, and TAN. Now, if we are talking about a different acute angle in a right triangle, let's say this one, then what would be opposite for this guy would be over here. And what would be adjacent to this guy would be over here, and the hypotenuse would remain the same. So that is how right triangles work. Let's look at this triangle, and we're going to write down what we think the sine, cosine, tangent, sine, cosine, tangent are for angle A and angle B. But first, I want to show you this memory trick. SOHCAHTOA is something that we say and use to help us remember how these things go together. So, SOH simply stands for that the sine of an angle is opposite over hypotenuse. CA stands for that the cosine of an angle is adjacent over hypotenuse. And TOA, TOA, means that the tangent is equal to the opposite over adjacent. Okay, that's SOHCAHTOA is a helpful memory trick. So let's look right here. The sine of angle A. Here's angle A is equal to opposite over hypotenuse. Opposite is A. Hypotenuse is C. Here's angle A. The cosine of A would be adjacent B over hypotenuse C. And the tangent of angle A is going to be opposite A over adjacent B. This is the truth for angle A. All right, now let's look at B. Angle B is here. What is, if we need the sine, we're going to look for opposite B. What's across from B is little b, and hypotenuse is C. The cosine of B will be adjacent, which is going to be A over hypotenuse C. The tangent of B is going to be opposite B over adjacent A. Okay. Also, I forgot to mention, when we're using this convention where capital letters represent the angles, lowercase letters represent the lengths of the sides. And we are also going to use the convention that capital B, the angle across from capital B will be little b, the length of the side. Across from angle A will be the length of A, which will be represented by little a. So the C's go together, the A's go together, the B's go together. Now let's talk about complementary angles. This is something that you saw a long time ago in middle school, probably. But what complementary angles are two angles that add up to 90 degrees. Two angles that add up to 90 degrees. Okay. So, for example, if we look at this triangle, we know that angle A plus angle B is equal to 90 degrees because this 90 degrees, these are complementary angles. Now, if we know two complementary angles, we can talk about a relationship between them. And this is it. If A and B are complementary, and they are, then the sine of angle A is equal to the cosine of its complement. 90 degrees minus A would be its complement, which means it's equal to the cosine of B. And if we look over here, we see that the sine of A is equal to the cosine of B. That's true. Likewise, we can say that the cosine of angle A is equal to the sine of 90 degrees minus A. Oh, come on. Let me do a better job. 90 degrees minus A, or the complement of A, the sine of B. And so we see that that is true. The cosine of A is equal to the sine of B because they are complements. And we could also write this vice versa. We could say that the sine of B is equal to the cosine of A, we could say that the cosine of B is equal to the sine of A. That's also true. All right, so that is good stuff. Now we're going to use our calculator. Get your calculator out, and you do not have to have a graphing calculator, but you can. I'm going to be using this one. If you have a different kind, a scientific calculator is all you're required to have. But what you want to do is we're going to make sure it can be in radian mode or it can be in degree mode, because we've heard of both of these. For this one, you want to you can press mode and you look right here, and whatever's highlighted is what it's in. Mine's in degree, which is what I want it in. I'm about to use buttons to get this, okay? Other calculators might, on the screen, it might say at the top DEG or RAD, and you'll know what mode it's in. All right, let's take the sine of 30 degrees. Here's my sine button. I'm just going to say sine of 30, and it tells me it is 0.5. All right, and they want 3 decimal places, so that would be 500. The cosine of 30, I hit my cosine button, and I put in 30, and I get 0.866. I'll put a 0 in front of that. The sine of 107, the sine 107, 0.956. The cosine of 78.27 gives me 0.203 to 3 places. All right. Now let's look at what if we want to be able to, what if they give us this number, 0.5, and say what angle has a sine of 0.5? What angle has a sine of 0.5? We could do the inverse relationship and find the angle. So we're about to do that. We're going to learn these buttons, and we'll see these again in the course. But where is the inverse sign, also referred to as the arc sign? So when they say arc, this means the same thing as inverse. This is the notation. Where do you see that? On mine, it is in blue above the sine button. Cosine inverse is above the cosine. Tangent inverse is above the tangent right here. Right above these in the blue are the inverse buttons. So what do? If I want to find the sine inverse, I know I'm in, your calculator will spit it out in radians or degrees, just depending on what mode your calculator's in. Mine is in degrees, so it's going to come out in degrees, and that's fine. You just want to be aware of that. Okay, so I want sine inverse. I'm going to hit my second button, sine inverse of 0.2917. And then I hit enter, and I get 16.96. I guess I'll go to 16.96. We'll go to 2, and this is degrees. All right. Let's do arc cosine. That means the inverse cosine of negative 0.1478. And that gives me 98.499 or 50 is what I would do, round that up to 0.50. If they want the arc cosine of negative 0.68, that's the inverse sine. I'm sorry, arc sine. Inverse sine of negative 0.68. That gives us negative 42.84 degrees. And if they want the inverse cosine of negative 0.541, that gives us 122.75 degrees. That's what we get there. All right. Now we're going to learn how to solve a right triangle. How you solve a right, what does it mean to solve a right triangle? This means find out all the unknown angles and sides. All the unknown angles and sides. That's what we have to figure out. So here is our triangle. It's a right triangle, and this is reserved for C. A and B can be interchanged. I'm going to call this A and this B. That means this is little a and this is little b. This is my right triangle. So number 1, solve the right triangle where little a is this, and big B is this. All right, so I'm going to redraw it. This is C. This is big C. This is little c. This is A. This is B. What did they tell me? They told me angle B is 32.4 degrees. And they told me that little a is 42.3 meters. We know that angle C, angle A, angle B, angle C they told me B was 32.4 degrees. We are given that C is 90 degrees. What I don't know is angle A. And what I also don't know are the lengths of side B and C, but they did tell me that A was 42.3. All right, we got that. Well, this is the easiest way to find angle A if they told me one. Since this is 90 degrees and these two add up to be 90 degrees, I can find angle A. It's equal to 90 degrees minus B. That's going to be nice. 90 minus 32.4 gives me 57.6 degrees. So that's that one. That's good. All right, now I need to find out the length of these other sides. So I'm going to use trig ratios to figure this out for my right triangle. What I know is A. What I don't know is B. What I'm going to do is come up with a trig ratio that involves A, something I know, with B, something I don't know. I'm going to choose angle B. They told me that. So I know that the tangent of angle B is equal to SOHCAHTOA opposite B over adjacent, 42.3. And I know that angle B is 32.4. They told me that. 32.4 degrees. Now, this is not the only way you could do this. Since we know angle A, you could come up with another ratio. This is just the one I'm going to use. So what do? How would I solve for B? I'm going to multiply both sides by the denominator, 42.3 times the tangent of 32.4 is equal to B. If I multiply both sides of this by the denominator, these will cancel. And so 42.3 times the tangent of 32.4 gives me that B is equal to 26.8. 26.8, and that's in meters. So now the only thing I have left to find is C. Well, I want to think of a trig ratio I can use that involves something I know and something I don't know. I know A, I know B, I know all the angles. There's a lot of choices I could use, but to say the most accurate will be to use the given information as much as possible. And so since they gave me angle B and side A, I'm going to try to use that. So I'm going to say, what could I use that involved something I know A and something I don't know C? Well, this is adjacent and this is hypotenuse. So I could say the cosine of 32.4 is equal to adjacent 42.3 over hypotenuse C. And this is a nice way to do it. Now, it is not wrong if you were to say, I'm going to use angle A and say that the sine of angle A is A over C. You could do that as well. But this is just how I'm choosing to do it. I'm going to multiply both sides by C to kill my fraction. I get C times the cosine of 32.4 degrees is equal to 42.3. And then I'm going to divide both sides by the cosine of 32.4, and that's going to give me C. So if I take 42.3 divided by the cosine of 32.4, I get 50.1, basically. 50.1 meters. And so now I have solved that right triangle. Last example. Solve the right triangle where A is this and B is this. Okay, so here is my triangle. This is C, this is little c. This is A, this is little a. This is B, this is little b. What did they tell me? They told me that A was 46.2 kilometers and that B is 22.0 kilometers. And they didn't tell me any angles. So I'm going to try to say what I got to figure out. Angle A, angle B, angle C. This is 90. Don't know. Little a, little b, little c. Don't know. Oh, I do know. 46.2, 22.0. Okay. Now, I'm going to use trig functions to do this. I know a lot of students, definitely, they love to use Pythagorean theorem to find C. That is allowed, but I'm introducing trig functions. I'm going to use trig functions to find all of these. So I want to find an angle A. Let's figure out what angle A is. I could have started with B, but I'm just picked one to start with. A, what do I know? I know opposite and adjacent. That makes me think tangent. Let me write down this. Tangent of angle A is equal to opposite 46.2 over adjacent 22.0. And they're both in kilometers. So what I'm going to have to do is say, how will I find angle A? Is I'm going to apply an inverse. I'm going to take tangent inverse. And what this does is it undoes that and it gives me the angle, just like we were practicing a minute ago when we were doing these arc stuff. All right, ready? Tangent inverse of 46.2 divided by 22 gives me 64.5. Angle A is 64.5 degrees. Well, once I know angle A, a nice way to find angle B is to subtract 64.5 from 90. 90 minus 64.5 is 25.5. Okay, and now if I want to find C, I'm going to use a trig function. I'm going to say, let's stick with A. Let's say that the sine of A is equal to opposite little a over C. So that means that the sine of 64.5 is equal to opposite 46.2 over hypotenuse. Again, you could have chosen a different trig function. There's lots of information you could use to get this. So I'm going to multiply both sides by C. And then to solve for C, I'm going to divide both sides by the sine of 64.5. So if I take 46.2 and I divide it by the sine of 64.5, I get 51.2. C is equal to 51.2. 51.2 kilometers. Okay, so that is that. I just want to point out one other thing. This is not coincidence. This is how it works. The length, the angle A is 64. Let's go over the smallest. The smallest angle, 25.5 in this case, has the smallest length across from it. The middle, 64.5, has the middle length. And the longest length will always be the hypotenuse. 51 is the longest because it's got the biggest angle. So the smallest angle has the smallest length across from it, and so on. All right.